You're tuned in to the Robert Joodat Podcast, where curiosity meets human peer review. Though the voice is artificial, the knowledge is authentic. Let's begin.
Your company has more data than it has ever had in its entire history, and somehow your teams are still making decisions by gut feel, spreadsheets, and whoever shouts loudest in the meeting room. That is not a hypothetical. According to research cited in a Medium deep dive on Foundry, enterprises spend somewhere between 60 and 80% of their time just finding, cleaning, and reconciling data, not actually analysing it. Today, we are cracking open Palantir Foundry, where it came from, how its architecture actually works, what this thing called the Ontology really is, and why some of the world's most complex institutions, from hospitals to operations, are real disseminates. Both in this episode, you should understand makes the besprees from past and difference upplace plafras than norming episode what the makes fascinating in structure rather than planets and.
So the place to start is really the problem Foundry was built to solve, because the architecture only makes sense once you feel the pain it's responding to. Most large organizations look like this on the inside, data living in dozens of siloed systems, ERP, CRM, IoT sensors, legacy databases, third-party feeds, and no single version of the truth. Finance has one revenue number, sales has another. Models get built by data science teams but never actually deployed because there's no bridge between those teams and the people making operational decisions. And compliance and audit trails are manual nightmares.
And that 60 to 80% stat is just staggering when you sit with it. That means the majority of a data team's working life is basically janitorial work.
Exactly. And that's the specific wound Foundry was designed to close, not one problem at a time, but simultaneously as a unified system. According to a detailed breakdown by Solan Das in Towards Data Engineering, Foundry launched commercially around 2016, but it was built on lessons from Palantir's earlier government-facing platform called Gotham. So the DNA of this product comes from some of the highest stakes operational environments on Earth.
Wait, so Foundry is essentially the commercial descendant of a government intelligence platform?
That's exactly right. And that lineage matters because it means the product was built backwards, starting from the most critical operational decisions, not from the data infrastructure up. Palantir's own documentation actually says they've spent more than a decade embedding alongside customers to build Foundry that way, encoding what they call tradecraft into the product itself.
That framing, building backwards from the decision, is actually a really different philosophy from how most software gets built. Most tools start with, here's what we can store, and work forward.
Completely different orientation. And you see that philosophy show up in the architecture. So let's get into how Foundry is actually structured, because this is where it gets genuinely interesting. The platform's architecture is built around a service mesh of hundreds of distinct elements. Each service operates in what the technical documentation describes as a highly available, redundant configuration, meaning the system is designed to keep running even when individual components fail.
So it's not one monolithic thing that goes down if something breaks.
Not at all. And one of the features that flows from that is zero downtime upgrades. According to Palantir's own architecture documentation, Apollo, which is the continuous delivery platform that sits underneath Foundry, enables the orchestration of thousands of zero downtime upgrades across hundreds of services and assets every single day. That's not a marketing claim. That's the operational reality of how the infrastructure runs.
Thousands of upgrades a day with no downtime. That's wild.
And the auto-scaling piece is handled by something called the Rubix engine, which extends across both the core Foundry services and what's called the Foundry compute mesh. The whole thing uses a consistent containerization approach, so it can handle dynamic workloads without being locked into any specific storage paradigm or compute infrastructure. It deploys different storage technologies at different architectural tiers, depending on what the workload actually needs.
And what about the data integration side? Like, how does data actually get into Foundry in the first place?
So at the foundation of the data integration layer is something called the Magritt Connector Framework. That's Palantir's name for its integration engine. And here's a fun tangent. Magritte is named after the Belgian surrealist painter, the one famous for the painting of a pipe with the caption, "This is not a pipe." It's almost like a philosophical wink. Raw data is never quite what it appears to be on the surface.
That is such a nerdy and wonderful naming choice. I love it.
Right? And beyond Magritte, Foundry also has what it calls HyperAuto, which enables automatic and dynamic pipeline generation for the most common ERP, CRM, and SQL data stores. The pitch is that you can unlock complex data estates in hours rather than months. And the platform is genuinely open. It connects to existing data lakes, warehouses, lakehouses, data science environments, BI tools, and more.
So it's not trying to replace everything you already have.
That's a key point. Palantir's documentation explicitly says you can incorporate data and models from your existing enterprise architecture without duplicating the underlying assets or fracturing existing sources of truth. And on the language side, Foundry supports Python, SQL, and Java for data transformation, Python and R for machine learning workflows, and TypeScript and JavaScript for defining workflows and front-end applications. So it's not forcing you into a proprietary language ecosystem.
And there's also this concept of treating data like code, right? I saw that in the documentation and it kind of stopped me.
Yeah, this is one of the more philosophically interesting things about Foundry. The platform brings Git-style branching, merging, and change management to data pipelines. So the same version control discipline that software engineers apply to code, you can now apply to your data. Every version of every dataset in Foundry indicates which code, which parent datasets, and which runtime created it. That's what they call dynamic data lineage.
So you can actually trace exactly where a number came from, all the way back through the pipeline.
Full provenance. And the security model is baked into that same layer. Foundry implements role-based, marking-based, and purpose-based access controls as what the documentation calls active and immutable metadata. It's not a bolt-on security layer. It's woven into the fabric of how data moves through the system.
Okay, so we've got the architecture, we've got the data integration layer, we've got lineage and security, but I keep hearing that the ontology is the real heart of Foundry. What actually is it, and why does it matter so much?
So this is the part that I think most people get wrong when they first encounter Foundry. They assume the ontology is just a fancy data model or a schema design tool. It's not. According to Palantir's own documentation, the ontology is an operational layer for the organization. It sits on top of all the digital assets integrated into the platform and connects them to their real-world counterparts.
What does real-world counterparts actually mean in practice?
So instead of working with tables and columns and rows, you work with real-world entities. An employee, an aircraft, a purchase order, a threat actor, a field service ticket. These are what the ontology calls object types. They represent real-world entities as nouns. And each object type has properties, which are its attributes, and link types, which define the directed relationships between objects. So employee reports to manager is a link type. Invoice contains line item is a link type.
So it's basically a semantic graph of your entire organization.
That's a great way to put it. And the Supply Chain Today publication describes it as the business-aware representation of an organization's entire data universe, turning raw data into actionable, real-world concepts that both humans and AI systems can understand and reason over. The phrase they use is that it's the digital twin of your organization's reality.
Digital twin is a term I've heard a lot, but usually in the context of physical manufacturing, like a digital replica of a factory floor. Using it for an entire organization's data universe is a different scale.
Much bigger scale. And what makes Palantir's ontology distinct from traditional static ontologies is what Grokopedia describes as operational dynamism. It's not just a descriptive model, it allows for active modifications and interactions that drive enterprise processes. That's where action types and functions come in.
Okay, break those down for me.
So action types are essentially the verbs of the ontology. They encapsulate business processes and write operations. Approve purchase order, dispatch technician, create alert. And here's the governance piece that I think is genuinely underappreciated. All writes to the ontology must go through action types. You cannot just directly update data. Every change has to pass through validation rules, approvals, audit trails, and side effects that are defined in the action type. The Supply Chain Today overview calls this preventing Wild West updates to data.
So governance isn't a policy you write in a document somewhere, it's a technical constraint baked into the system.
Exactly. And that's a fundamentally different philosophy from how most enterprises approach data governance. Most organizations have governance frameworks that live in PDFs and wikis that nobody reads. Foundry makes governance something the system enforces, not something humans are supposed to remember to follow.
That's actually a pretty profound shift when you think about it. And what about functions?
Functions are reusable logic or calculations that operate on ontology entities. The Supply Chain Today breakdown compares them to stored procedures. So something like calculate utilization rate for an asset. And then there's a newer concept called interfaces, which provide what's called object type polymorphism, meaning multiple object types can be treated uniformly if they share a common shape. It's a more advanced abstraction layer that makes the ontology more flexible as organizations scale.
And the big benefit of all of this is what? Semantic consistency?
Semantic consistency is a huge one. The supply chain today overview puts it well, everyone, analysts, data scientists, AI agents, executives, speaks the same language. A customer means the same thing everywhere in the organization. No more finance having one definition and sales having another. And the downstream benefit is AI readiness. Large language models and Palantir's own AIP agents can directly query and reason over the ontology using natural language, because the objects, properties, and links have clear business meaning.
So the ontology is also what makes the AI layer actually useful, because the AI has something coherent to reason over.
That's the connection. And this brings us to the broader architecture that Foundry sits within. According to Palantir's official documentation, the standard Palantir architecture consists of 3 integrated platforms: AIP, Foundry, and Apollo. Foundry is the foundational data operations platform. AIP is the generative AI platform, providing secure connectivity to large language models. And Apollo is the continuous delivery platform managing the underlying infrastructure.
So Apollo is basically the invisible engine room keeping everything running.
Exactly. And together, Palantir describes AIP plus Foundry plus Apollo as an enterprise operating system. The documentation maps the combined platform into 9 capability sets: the ontology language, ontology engine, and ontology toolchain, which together constitute the ontology system, plus data services, logic services, and workflow services that power it, and then analytics and applications, automations, and a product delivery toolchain on top. All of that runs on 6 mesh-wide components: storage, compute, networking, security, governance, and the workspace.
That is a lot of moving parts. And the security model across all of this, how does that work?
The security architecture spans all 3 platforms in 3 spheres: infrastructure security, platform security, and enterprise security. At the infrastructure level, every component in the Palantir service mesh operates with what they call zero trust, meaning all elements are access gated based on identity, device health, and verification. And the system is designed with an expectation of hostile attacks, with autonomous enforcement through Apollo-mandated encryption, firewalls, and runtime configurations.
Zero trust by default, not zero trust as an add-on. That's a meaningful distinction.
It is, and it makes sense given where Foundry came from, a platform originally built for government intelligence work. You don't bolt security onto that kind of system after the fact.
Let's talk about where this actually shows up in the real world, because I think that's where it gets tangible. The Palantir documentation mentions some pretty striking use cases.
Yeah, and the range is genuinely remarkable. According to Palantir's official architecture documentation, the enterprise operating system powers AI-enabled care operations at major hospital systems, integrated network planning for major airlines, electric operations and wildfire response for America's largest utilities, and full-spectrum military operations across the United States and allied nations. And on the commercial side, Palantir's own platform page mentions use cases like building safer cars, securing global supply chains, and accelerating cancer research.
Wildfire response and cancer research on the same platform. That's a pretty extraordinary range.
And it speaks to the generality of the architecture. The ontology doesn't care whether the objects it's modeling are aircraft or invoices or patient records or threat actors. The underlying machinery is the same. That's the power of building a truly general operational layer.
What about the financial services angle? I saw anti-money laundering mentioned specifically.
Right. So, according to the LinkedIn deep dive by Gal Levenstein, Foundry provides robust solutions for anti-money laundering and transaction monitoring. The advanced analytical capabilities let users detect suspicious activities, ensure compliance with regulatory requirements, and mitigate risks associated with financial transactions. And that's a domain where the governance by design approach of the ontology is particularly valuable, because in financial compliance, you need an airtight audit trail of who touched what data and when.
Mm-hmm. And Forrester actually recognized Foundry for this kind of capability, right?
Yes. According to multiple sources, including the LinkedIn analysis, Forrester named Foundry a leader in the Forrester Wave for AI and ML platforms in Q3 2022, scoring the highest marks possible in product vision, performance, market approach, and applications criteria. That's a meaningful external validation from an analyst firm that evaluates these platforms rigorously.
Now, I want to push back a little because not everything about Foundry is frictionless, right? There are real challenges for organizations trying to adopt it.
Absolutely. And it's worth being honest about this. The Medium Technical Anatomy piece by Joshua Jones is pretty direct. The architectural complexity could prove challenging for organizations with limited technical resources. The service mesh of hundreds of distinct elements is powerful, but it requires a deeper understanding of data management principles to utilize optimally. And the broad language support, Python, SQL, Java, R, TypeScript, JavaScript, is great for technical teams, but organizations with limited technical expertise face a steep learning curve.
So it's not a plug-and-play solution. You need real technical depth to get the most out of it.
That's fair to say. And the ontology itself requires significant upfront investment to build correctly. Mapping your organization's real-world entities, defining the relationships, encoding the business logic into action types and functions, that's not a weekend project. It's a substantial architectural commitment.
But the argument is that the payoff on the other side of that investment is a system where everyone is working from the same semantic foundation.
That's the bet. And the Palantir documentation frames the goal of the ontology investment very clearly, to facilitate better decision-making in an organization at scale. The ontology is deeply integrated into the user-facing analytical and operational tools. Users can create reusable object views, search for objects in Object Explorer, perform complex analyses in a tool called Quiver, and build applications in Workshop. The whole stack is oriented toward getting the right information to the right decision maker at the right moment.
And that's the closed-loop operations concept, where decisions feed back into the system and the system learns from them.
Exactly. Palantir's platform page describes it as a dynamic system for closed-loop operations, where you capture decisions for continuous learning. So it's not just about making one good decision, it's about building an institutional memory of decisions that makes the next decision better. That's a very different value proposition from a traditional business intelligence dashboard.
A BI dashboard shows you what happened. Foundry is trying to be part of what happens next.
That's a clean way to put it. And the Grokopedia analysis makes a point that I think is underappreciated. The ontology integrates semantic, kinetic, and dynamic elements of enterprise systems, ERP, CRM, industrial databases, real-time sensors, without requiring alterations to the underlying sources. You don't have to rip out your existing systems. You layer the ontology on top of them.
Which is a huge deal for large enterprises that have decades of legacy infrastructure they can't just replace.
Massive deal. And it connects back to the data lineage piece, because every version of every dataset in Foundry indicates which code, which parent datasets, and which runtime created it. So even as you're layering the ontology on top of legacy systems, you maintain full traceability of where everything came from.
Let me ask you something that I think a lot of people wonder about Palantir specifically. There's a lot of mythology around the company. Does the product live up to the hype, or is some of this just very good marketing?
It's a fair question. And I think the honest answer, based on what the search results actually show, is that the architecture is genuinely sophisticated. The modular service mesh, the Rubik's autoscaling engine, the zero trust security model, the ontology as a governance layer, these are real technical innovations, not marketing language. The Forrester recognition in 2022 is an independent data point. But the complexity is also real. This is not a platform you deploy and immediately get value from without significant investment.
So the mythology cuts both ways. People either think it's magic or they're skeptical it's all smoke and mirrors, and the reality is somewhere more nuanced.
Solon Das in the Towards Data Engineering piece from April 2026 actually puts it well. Palantir evokes strong opinions, admired by some, mysterious to many, misunderstood by most. And the honest framing is, strip away the mythology, and what you find is a genuinely powerful data platform that is reshaping how large organizations think about, manage, and act on their data. That's not a small thing, but it's also not magic.
Not magic, but genuinely powerful. I think that's actually a more compelling pitch than the mythology.
Because it's honest. And the use cases back it up. Wildfire response, military operations, cancer research, anti-money laundering. These are not domains where you can afford a platform that's all marketing and no substance.
So when you step back from everything we've covered today, the origins in Gotham, the modular service mesh, the Rubik's engine, the Magritt connector, the ontology with its objects and action types and functions, the three-platform stack of AIP, Foundry, and Apollo. What's the through line? What's the thing that ties all of it together?
The through line is the shift from data abundance to decision readiness. Every architectural choice in Foundry, the modular service mesh, the ontology as a governance layer, the closed-loop operations model, the zero-trust security, all of it is oriented toward one outcome: getting the right decision made faster, with more confidence, and with a full audit trail of how you got there. The problem Foundry is solving isn't a storage problem or a compute problem. It's a decision problem.
And the ontology is the mechanism that makes that possible, because it's the layer that gives data meaning in the context of the organization's actual operations.
Right. And the constitutional framing I keep coming back to is this. The ontology doesn't just describe your organization, it governs it. Every right goes through action types. Every relationship is explicitly modeled. Every piece of data has a lineage. That's not a data model. That's an operating system for how your organization reasons about itself.
Here's what this really comes down to for anyone listening who works in data or leads a team or is trying to figure out why their organization keeps drowning in dashboards but still can't make a clean decision. The problem probably isn't that you don't have enough data. It's that your data doesn't have enough meaning. And that's the gap Foundry is designed to close.
And the actionable insight from all of this is actually pretty simple. Before you invest in more data infrastructure, ask whether your organization has a shared semantic layer, a common definition of what a customer or an order or an asset actually means across every team. If the answer is no, you're going to keep spending 60 to 80% of your time reconciling data instead of acting on it. That's the problem the ontology solves, and it's a problem worth solving regardless of which platform you use to solve it.
That's a genuinely useful frame. And it's interesting, we started this episode with the observation that enterprises are drowning in data but starving for decisions. And what Foundry is really arguing is that the solution isn't more data, it's a smarter relationship with the data you already have.
And a smarter relationship with the decisions you're already making. The closed-loop model, capturing decisions for continuous learning, means the system gets better every time someone acts on it. That's the compounding value that's hard to see from the outside, but is probably the most powerful thing about the platform.
Compounding decisions. I like that. All right, we open this episode with the gut punch of enterprises spending the majority of their time cleaning data instead of using it. Here's the closing thought. The next time someone in your organization says we need more data, push back and ask, do we need more data, or do we need our data to mean something? Because if it's the latter, you're not looking for a bigger database. You're looking for an ontology. Thanks for being here for this one on Copilot Podcasts, and we'll see you next time.